So here we see that we're working with a regular nonagon, and so a nonagon is a figure that has 9 sides. They want us to find the measure of angle JKL. We always concentrate on the middle letter, so that's K, and as we can see, that is an exterior angle. So what I want to do is I want to extend the angle, the interior angle from the triangle, so that we can see what the exterior angle is here. So when I extend that, I see that my exterior angle, my interior angle is going to be 60 degrees because in a triangle, when all sides are congruent, all angles are congruent. So if the interior angle is 60, then the exterior angle is 120 degrees. Now we want to find the exterior angle of the nonagon. So I'm going to use my formula, n minus 2 times 180. That's going to get me all the interior angles, and then I'm going to go back and divide it by n. So once I put it in the formula, I find out that one interior angle is 140 degrees. So I'm going to go ahead and write that in for the inside. One interior angle is 140 degrees. Well, if that is one interior angle, then the exterior angle, supplementary linear pair, is 40 degrees. So the measure of angle JKL is made up of 40 degrees plus 120 degrees, voila, for 160 degrees. In this video, we'll be going over reporting category 3, which is circles, polygons, and 3D figures. Feel free to pause the video and try the problems, and then watch as I model through how to think through these type of problems. So for this particular problem, we're looking at a circle. The formula is on the formula sheet, and the formula that is given to you on the formula sheet looks just like this. So let's take a look at our points that represent the center. It's -4 and 1. So over here is going to be the opposite. So that means our inside value is going to be, instead of x minus 4, it's going to be x plus 4. And it's going to be opposite the positive 1, so it's going to be y minus 1. We don't know what r squared is right now. So x plus 4, well, this one isn't x plus 4, so we'll go ahead and eliminate those. So we have it down to the last one, x plus 4, y minus 1, x plus 4, y minus 1. Well, nothing else needs to be done. Just make sure with these type of problems where you see circle and center, refer to your formula sheet. For this particular problem, we have to read through the directions carefully. It wants us to find the surface area. However, we have a combination of two figures. Keep in mind that as we find the surface area, the bottom of the cone is not shown and the top of the cylinder is not shown. Why? Because they are connected. So we're going to have to take that out when we find the surface area. So if we find the surface area of the cone, putting everything in the formula, we get 942 feet squared. Keep in mind that we have not subtracted the area that it has in common, the two figures have in common. Okay, so now I found the surface area of the cylinder. So I have the surface area of the cylinder, the surface area of the cone. If I add the two together, I don't even see that answer here. It's because I have not taken out the area of the circle that they share. So what I'm going to have to do is I'm going to have to subtract pi r squared on both of these, minus pi r squared. Well, what is pi r squared? Well, pi is 3.14 and our r squared is 12 squared. Alrighty. So when I subtract out the area for the circle, I get 1205.76. When I subtract the area for the circle, here I get 489.84. Last step, let's add these together. And we get 1696. For this particular problem, it is a circle. So I want to think about what I know about a circle. So what I know about a circle is that if the angle is inscribed, which means it's on the circle, then the angle is equal to half the arc. Okay. If it's somewhere in the middle, then I know the angle is equal to half of the two intersecting arcs. So for right now, let me fill in everything that I know. I know that if this angle is 92, the angle across from it that's vertical is 92. What I also know is that this angle here is 38 degrees. So I have all the angles inside of the triangle. I don't have any other information about Q or T. However, if I look, I can see that angle R, that was a little too big, that angle R here, the intercepted arc is ST. So if the angle is half the arc, and this is 38 degrees, then this is 76. Because if the angle is half the arc, then the arc is twice the angle. Well, take a look. That same arc is connected to Q. Because if I extend it out, take a look, it's the same arc. So if this arc is 76, then the angle here is half that arc. So then Y is also 38. Make sure you take your time on the test and read through the questions. We can see that the height was, we're told that the height of the box is 4 centimeters, but it says the height of the original box will be increased by 3.5. So the new dimensions of my box is going to be 7.5 is going to give me the height, and 18, so this is the height, and 18 is still going to be the length, and 13.5 is going to be the width. Let's take a look and see what we're looking for. We're looking for surface area, so let me write down the formula. Okay, so we put everything in the formula, and we get 486 plus 270 plus 202.5, and that gives us close to 959. Got 958.5. So you have to read the questions carefully. This problem, we're told that it is a rhombus. A rhombus is still a parallelogram. And so with a rhombus, we have 90 degrees for diagonals. They're perpendicular. And the angles bisect. So if this is 36, this is 36. The one across is 36, and this one is 36. So this whole angle here is 72, and this whole angle is 72. We also know with a parallelogram, the angles right next to each other are supplementary. So that means this angle over here, the whole thing is 108, and this one over here, the whole thing is 108. Well, if the angles bisect, the diagonals bisect the angles, then this is 54, and this is 54. So now what we need to do is figure out, what are they asking from us? What's the measure of angle D to A to E? So if I go from D up to A and back to E, the angle that I just circled would be 54. So for this particular problem, the formula is given on the formula sheet, and how to read it is also given. So it says we have a circle with a center of -2, -2. And so if I were to write out my equation, it would be x plus 2 squared, y plus 2 squared is equal to r squared. Well, if you're given the diameter, the radius is half the diameter. So the radius in this case is 5. And 5 squared is 25. So back to the question. Which point lies on the circle? Well, with this, what we can do is we can plug in our values, because anytime it is actually on the circle, we can plug in our values to see which one will give us 25. So let's start with A. We're going to let x equal -6, and we're going to let y equal -5. Let's see what we get. Alrighty, so we plug in our first set of values for A, and that was -6 and -5, and so I replace my -6 with x and my -5 with y, and I simplify. When I simplify, I get 16 plus 9. The question is, does 16 plus 9 equals 25? Yes. So that means my answer is A. If I happen to plug in a point and it did not come up to 25, then it does not lie on the circle. Reading through the questions very carefully, I see that this one is asking for the length of the railing needed on a circle. So you have to recognize that they're asking you for the arc length, which the arc length formula is not given. However, on the formula sheet, the circumference formula is given, and it is 2 pi r. This is for the whole circle. We don't want it for the whole circle. We just want a part of it. So the formula is going to be x over 360 times 2 pi r. So our x is going to be the angle of the arc. And so in this case, it is 70. So we're going to do 70 over 360 times 2 times pi times 40. And let's see what we get. And this comes to 49 feet. So 49 feet to walk along this arc. So anytime you see polygons and interior angles, we have to go to our formula, which is n minus 2 times 180. And this is going to tell us the total of all the angles inside the figure. Well, this figure has how many sides? Exactly, 6 sides. And so you put it in the formula and you find out that all the angles are going to come up to 720 degrees. Okay, so we have 90 and 90, 150, 150, and we don't know what this is, and so we're going to call it X. So we have all the interior angles, and we set it equal to 720, and we solve. And we find out that each angle is 120. So for this problem, it says the volume of a cube is 64 cubic inches. And so a cube looks like this. And so what we know is that the volume is 64 cubic inches. We know that the length, the width, and the height is the same, but we don't know what that number is. So what you can do is you can go to your calculator and tap the button that says math. And when you tap it, you can go down to button number 3, and it has cube root. So if you take the cube root of 64 and then hit enter, it'll tell you that your x is equal to 4. So that means each side of your box is 4, the height, the length, and the width. Now that we know that, we can find the surface area. So once we put it into the formula for surface area, we get the surface area is equal to 96 cubic centimeters. So for this particular problem, they're trying to see if you know your properties for a rectangle. So it says that the rectangle is called KLMN. And it intersects at 2, 1. So we're going to go over to 2, 1, and we're going to put a dot here at 2, 1. It says one of the vertices of the rectangle is located at -4 and 5. -4 and 5. So that's right here. That's one vertex. And so what we know is that the diagonals of a rectangle are the same. So let me go over 1, 2, 3, 4, 5, 6 and down 1, 2, 3, 4. So I went over 6 and down 4. I'm going to do the same thing. Over 6, 1, 2, 3, 4, 5, 6 and down 4, 1, 2, 3, 4. So here is one vertex. And look at that. It happens to be the one that's right here. However, we could do the same thing to get to our other vertices. We just go in the opposite direction. But since we don't need to do that, there we go. But just in case, we would steal from the vertice, go down 4 and over 6. And guess what? We did just create the rectangle. There you go. Because all the diagonals will be congruent. All right, there's a better picture right there. Reading the question, they want the area of the shaded region. So when we look at area on our formula sheet, it says pi r squared, but this is the area for the whole figure. We don't need the whole figure, we need a fraction of the figure. So we're going to alter the formula by doing x over 360 times pi r squared. The x for the shaded region is 130, so it's 130 over 360 times 3.14 times 5 squared. And the closest area is 28.34 centimeters squared, which matches B. So here it says a ratio of the radii of two spheres is 3 to 5. What is the ratio of the volume? So this is one of the problems where we have A1, B1, A2, B2, and A3, B3. So this would represent surface area and this would represent volume. So here we would have 3 squared, 5 squared. And here we'd have 3 cubed, 5 cubed. So let's figure out what this is. This one will be 9 to 25, and this one will be 27 to 125. And again, you can use your calculator and go to the math key and raise this to the third power to get your answer. So 27 we will put right here, and 125. Notice how they have 9 in here as one of the options and 25, and they still have 3 and 5. So just be careful with that you read carefully that we're looking for the ratio of the volume. Reading the question carefully, it says it's an isosceles trapezoid. So with an isosceles trapezoid, the base angles are the same. So this is 55, this one right here is 55, and that base is 55. Remember that a trapezoid has parallel sides, and so our other angle is going to be 180 minus 55. So now that we have found the interior angle of the trapezoid, 125, the other one is also 125. Let's move to the octagon. Octagon has 8 sides, so we're going to find out what all the angles add up to, and then we're going to find one. So one angle in the octagon is 135, so this angle right here is 135 degrees. Well, what we're going to do is, because this is an exterior angle, let's just go ahead and split it. So the supplementary angle to 125 is 55. So this angle down here is 55, which makes sense because it's alternate interior. So that's 55. The angle at the top, the exterior angle is going to be 45 because the interior angle is 135 and they add up to 180. So I need this complete angle. And so what does it add up to? Total's 100. So this problem wants us to actually plot the center of the circle. The formula is definitely given. And the formula is x minus h quantity squared and y minus k quantity squared is equal to r squared. And they also tell you that h and k is the center. So it's going to be the opposite. So the opposite of this is going to be 4, negative 4. And the opposite of this one is going to be 5. So our coordinates are going to be negative 4 and 5. So I start here at the origin, and I go over 4, and I go up 5. So voila, there's the center. So in this particular problem, it says find the volume of the pyramid. So we go to our formula sheet and we write down the formula for the volume of a pyramid. Volume is equal to 1/3 big B times H. Remember that big B is the area of the base. And so here we can see that the shape of the base is a rectangle. So we need to find big B. Big B is going to be length times width. So big B is 108 centimeters squared. So now we're going to put that in the formula. 1/3 of 108 times the height, and it is 8. And let's see what we get. 288 centimeters cubed. So as we read through this question, a company is creating a new cylindrical container. The new container will have 4 times the volume of the original container. The height of the new container will remain the same as the height of the original container. Okay, so this one may take a little bit of time. We set up our volume formula. Volume is pi r squared h. We have an old volume and a new volume. Here it says that the new container will remain the same as the height of the original container. So the height of the new container is going to stay the same. So take a look down here. I got my height. I picked an easy number. I picked 1. And over here I have 1. In A it says the radius has doubled, so it's twice the size of the original. So I'm going to let my first radius be 1 and twice that will be 2. I'm going to figure out what this is and then I'll compare it. If it's 4 times the volume, we're done. If not, we'll do this again and we'll make our R1 and we'll make a new R4. All right, when we filled it in for our first one, we got that the volume was pi when we let everything equal 1. And over here when we did it, we had 4 pi. You always, when you're comparing, will divide. So 4 pi over pi gives us 4. And voila, we found it. 2 times the length of the radius will make the volume 4 times the original. Yay! That concludes our reporting category 3.